Good morning, everyone. Good morning, good afternoon, good evening, good day. My name is Adrian Goins. I am the Director of Community here at Rancher, and I am joined by Pavan Shankar and Vicente Herrera, who are from Sysdig. They're here to present today on detecting anomalous activity in Rancher with Falco. They have a lot of stuff to go over today, so we're going to hand it over to them in just a moment. But before we do, I want to wait a moment and let a few more people roll into the webinar because we have a lot of people joining today. So a little bit of housekeeping. First of all, the instant that the webinar started, the first question that we got was, will we get the webinar slides over email? Yes, this is being recorded. So if you have to drop off for any reason, don't worry about it. After the session, you will get a follow-up email that has a link to the video itself so you can watch it again and a link to where the slides are hosted. So you'll get all that. Other minor housekeeping is if you look in the GoToWebinar panel, you'll see that there's a questions pane. And in fact, some of you are already using it. As we're doing our presentation today, if you have any questions whatsoever about the things that you are seeing, please ask them there. And the guys will stop occasionally throughout to answer questions. And also there will be a Q&A session at the end. So as soon as you think of a question, post it there. The only thing I ask is because we are limited on time, we want to try to keep this to an hour. Try to keep the questions on topic. If you have a question that deviates from this, you might get a reply directly in the chat, saying that you can go to the Rancher user Slack, or one of the Sysdig guys might tell you where to follow up with those kinds of questions. But every other question about what you're seeing today, Falco, security, Kubernetes, all of that stuff, put them out there and we'll do our best to answer all of them. And I guess that's really it. So I think we can just hand it off to them. Pavan, are you ready to begin?
Yes, sir. I'm ready.
All right, take it away.
Welcome, everybody. I'll introduce myself first, and then I'll let Vicente go next. My name is Pavan Shankar, and I'm responsible for product marketing here at Sysdig for our security product, Sysdig Secure. And I've spent about a year and a half here at Sysdig, and prior to that, I was at another startup called Dome9 Security in the cloud security space. And part of that, I was a solutions engineer for about 9 years at Cisco. And I'm really excited today to talk to you about runtime security detection using Falco in Rancher environments.
Well, hello, my name is Vicente Herrera. I am part of the cloud native team at Sysdig, where we develop integrations with different products. We help develop new features like compliance. We also help with tech marketing, and we're like a mixed team that are involved in several things at the same time.
So on the agenda today, we have a couple of key items to discuss. First, we'll talk a little bit about why runtime security is important in Kubernetes and Rancher environments. We'll talk a little bit about the open source Falco project and Rancher, and talk a little bit about how you can get started with Falco, go over installation and configuration components, and then we'll pivot and talk about some of the key Falco rules that you can use to detect abnormal activity in Rancher environments. We'll go through step by step many of these rules and show you the rules in action and demo how you can detect many of these threats, both at the system level and at the Kube API server level with Falco. And we'll spend a brief amount of time just quickly talking about how you can extend Falco with Sysdig Secure, and then cover any additional questions along with resources that can serve you as a great companion to this webinar. So let's get started. Okay, so the first thing to talk about is why runtime security is important. So when teams typically think about container security, they're often usually thinking about scanning their images, which typically is the first step as they embark on their container adoption. And image scanning is an important step where you need to ensure that you're scanning for vulnerabilities and misconfigurations early in the pipeline. So embedding it into your CI tool, scanning your registries, and that's a very critical step. But runtime security is also very important to detect any additional malicious behavior. So even after an image is deployed and scanned, some things can potentially change inside that container. Perhaps someone exec into that pod or container and downloaded a package when they shouldn't be, because this container infrastructure was supposed to be immutable. Maybe a specific team member got access and did something different that caused a drift in that image. So having a runtime security detection capability in place allows you to detect those kinds of events that occurred. The other component is sometimes new ODAs or new vulnerabilities come out. So even though you did the right thing by scanning early, new CVEs might come out that might be affecting your running images. So being able to report on those vulnerabilities at runtime and being able to specifically know exactly where they occurred, which namespaces, clusters, deployments, or pods, that's something that you need to have a runtime detection mechanism in place that can detect those threats and alert specifically at runtime. And then from an alerting an incident response perspective, being able to alert on activity that happens right away. So maybe someone downloaded a malicious Python extension, or connected to a crypto mining port, for example. Being able to immediately detect that, especially in a container environment, is important because most of these containers live for several seconds, few minutes. So having the attackers have an easier path to basically obfuscate what occurs within a container. So being able to detect this immediately is critical in these environments. And then plugging into your notification tools and incorporating alerting into your incident response workflow. So whether you're using channels like PagerDuty or Slack, making sure that somebody knows how to respond to that problem. And finally, from a forensic standpoint, gaining the ability to have a full audit trail of exactly what occurred if someone did something malicious within that container. So knowing all commands that were executed, what files were touched, all of that activity is important to know from a runtime security perspective if something did occur. And this is critical not just for incident response, but also for use cases of compliance. Many compliance frameworks like NIST and PCI define the ability to have an audit trail, define the ability to be able to show proof of compliance. And this is critical to have a capability that allows you to detect and respond, as well as provide an audit trail when something does go wrong. So how does runtime security fit into your overall workflow? So the way we define this workflow, when you think about container security and monitoring, is this three-step phase of build, run, and respond. So starting in the build phase, like we said earlier, ensuring you're kicking off security early and having security meet the developer with the tools that they're using. So if they're using Jenkins or Circle CI Bamboo, embedding security and scanning into their pipeline, as well as scanning any images that are sitting in the registry. And then being able to scan for vulnerabilities, not just for vulnerabilities, but also for potentially misconfigurations. Did a developer expose SSH in a Docker file, for example, or embed AWS secrets or access keys? Catching these early in the process is definitely something that can be leveraged using an image scanning solution. From a runtime security perspective, again, having the ability to report on new vulnerabilities, as well as detect any abnormal events that might be occurring, and then also using the telemetry and monitoring data to report on any specific violations or anomalous activity. So, for example, if someone launched a denial of service attack, perhaps the first way to detect that could be some spike in CPU or some spike in memory. And having that telemetry data that helps you respond quickly to these events, it can be very useful in this Kubernetes environment. And then finally, from a response standpoint, that's where runtime security connects into response workflows. So having a framework for incident response, being able to forward these detection events and alerts into a SIM tool of choice like Splunk or syslog, and having the ability to capture detailed audit when something does occur, that can be used for compliance, that can be used for forensics and incident response. So now we'll talk a little bit about Falco and how it came about and why it's useful for runtime detection. Okay, so Falco is the open source runtime detection engine, and it's a runtime security project that's the de facto Kubernetes threat detection as part of the CNCF. So we created Falco in 2016 and contributed that to the CNCF. It joined as a sandbox project, and recently, last October, became an incubation level project. So it's gained a lot of momentum in the open source community for runtime security. And also, it has a lot of users and contributors that are providing new rules that allow us to build on an open source model and an open source DNA to extend security for containers and cloud native applications. So, why are people thinking about Falco? So, as signature-based approaches, typically the challenge with signature-based approaches is that they must typically list possible exploits or vulnerabilities or attacks in some way, either via using some sort of malware signatures. So typically these approaches are engaged in some sort of never-ending game of catch-up with constant stream of new threats. The way to approach this for container environments is to look at behavioral activity monitoring approaches. So tools like Falco that is able to detect and alert on exactly what's happening on the kernel. So by detecting what happens, potentially if an attacker has access, allows teams to quickly respond to a specific event. And with Falco, you're deploying Falco as an agent on the host itself, and the system calls are monitored directly using a probe or using an eBPF probe, and you're gaining that visibility into the full stack of all the system calls that are traversing that kernel. So everything from network connections, file activity, process activity, commands that run, and this allows you to alert on any sort of malicious activity that's occurring at the system level. But beyond the system call level as well, what we also allow you to do is leverage the Kubernetes API logs as another source for detection. And examples of these could be, if someone is storing credentials in a config map rather than secrets, for example. Falcon can detect that kind of activity and track those changes that are made to your cluster. And if someone is creating a node port service or some other scenarios, these are all suspicious activities that are logged at the APS server and are performed through the APS server. So this audit log can effectively track all of those user activity changes as well. So being able to detect abnormal activity at the system level as well as at the Kubernetes API server level, and then correlate those two sources of information is something that becomes a use case for many of our customers. Great, and now I'll pass it over to Vicente, who will talk a little bit about installing Falco and how to configure for runtime security.
Thank you, Pavan. Okay, so I'm going to talk about the installation and configuration of Falco and to show some slides, but then also a little later, we're going to do a demo, a hands-off, and try things, move things around. So first, how do we install Falco? Well, Falco requires a daemon set to be deployed on the Kubernetes cluster to be able to live on each of the nodes and be able to capture all the kernel syscalls. And to do this, there are several manual steps that we can do, but also we can use a Helm chart to very easily deploy the Falco version we want and upgrade it when we need it, change rules, change the configuration, etc. When we install when we install Falco, we're going to find several interesting configurations that I'm going to show later, but one of them that it's very important is the output targets. By default, Falco is going to show us the output log like in the default console, and we can tap into it with kubectl to see all the logs, but we want them to be sent maybe to another kind of source so we can process it better. So we can tell the configuration to write it to a file. We can use gRPC to send it to a remote system that processes it, or maybe just an HTTP output with sending a post message, or even syslog, so it can be processed with any syslog capable program that takes this kind of log. So about Falco rules, this is the main thing we want to know more about. How they work, what can we detect, how is this set up inside. So in the Falco installation, we're going to find several files, and the Falco rules that Falco comes with by default are on two of them. There are Falco rules.yaml and key8s audit rules.yaml. These files have Falco rules for general system calls and Falco rules for Kubernetes related rules. Falco rules use a very simple language that is very easy to read. So even if you have never seen Falco rule before, you are going to more or less understand what's going on about that. And you can define in Falco lists and macros to help you write the rules. Lists are just, well, that a list of elements can be names for files, for ports, for binaries, for whatever you need to address in a list. And a macro is a Boolean condition that you can pack inside like a function, so you can reuse it in several rules and make more cleaner the writing of the rules. So in this case, we have first a list that is showing names of files that can have sensitive information, and we may want to protect and know when it has been accessed. And also, we can have the macro that tells us that someone is doing something with these files in a directory that starts with etc, and or it's part of etc source or path. So how does a rule work? Well, in this case, a rule has several parts. The rule keyword is going to have the title of the rule. It's just a placeholder that is going to be used when we see statistics about rules triggering. The condition is the Boolean part that is checked to know if the rule has to trigger. Here is where we use the macros and the lists, okay? And we are using some keywords that address specific system calls from the kernel that has information about the process, about the file description that's being accessed, the port of a connection, etc. And also we use lists to know if this, for example, if this process name is in this list of database server binaries. We use a macro here, expand process, that returns true if there is a new process being created. And in this case, we check that the process is, in this case, in the database server binaries, and it's not progress. Sorry, it's not Postgres in the Postgres database. So when the rule triggers, we're going to get a message in the output target we have defined. It's a simple text message where we can also, at the same time, again, use these kinds of placeholders that are going to be replaced by the different values that the kernel system call has. So we can know all the information about this. Source tells us that this is a rule for a system call and not for Kubernetes audit. And description is just a simple text that we use to know ourselves what's the rule about, a very simple one. Priority is going to be able to help us when we receive several rules triggers and we want to classify them and notice if someone is of a critical level. And also tags is also useful for us to be able to group together several rules of the same kind and know a little bit more what they are about. So in the default Falco rules file, we have many rules that are already defined there. So Falco is not only a detection runtime, It comes with a lot of very useful rules already written, and it has several macros, several lists that are very helpful to be able to do detections that we are going to see. This is a simple chart where we can see different kinds of detections we can do according to meter. And you're going to find all these rules in the Falco file rules, and you can read more about that in our blog post about all the rules that are there. Let me at least show you a little bit about these files. So this is the Falco rules files. You can see several macro here that are going to help us know if we are opening a file to write, opening to read, a directory. This is a true-false placeholder that we can use to maybe enable or disable rules. So binaries that are part of core utilities for the Linux system, binaries that handles passwords, so we know that they are fine trying to access password files. It's a very, very, very long list, as you can see, but it makes understanding rules and writing new rules easier, because when you get to the rule, you don't have a very long list of very strange names you are using. You just address those macros, you address those lists, and you say, for example, if you want to know if someone has scheduled a new cron job, well, you have this macro that tells you that you have to consider cron jobs. There is some file that has been opened to write. The file starts with etc cron, or there is a new span process that has the process name cron tab. So it's very easy to understand the rule, and it's very useful to have all these lists already pre-written. Okay. So when you want to write a new rule, we're going to talk about that also later. You should always try to start with a rule that is similar to the one you want to write, and start modifying it a little bit. Is the best way to learn how to do it for someone that is doing it for the first time. So let's do a little bit of demo about the rules being triggered, and I'll also go by the rules again when we're going to do the detections to explain a little more about these things. So I'm going to tell you again how to install Falco. We can do a little test about that later. We're going to test a rule that detects a terminal shell in a container and talk about what it's detecting and how it's working. We are also do the same for binary files modification. We are going to detect crypto mining activity. That's very interesting nowadays. We're going to detect someone trying to do secret exfiltration, someone trying to look for sensitive files that have secret values or passwords. And then we're trying to come up with a new rule to protect WordPress files. This is a rule that is not published in the Falco project or anywhere, and we are going to think about how we could do that, okay? So, to install Falco, as I've said, you can just use the Helm chart and run install Falco, and you have to wait some minutes until every pod is spawned and everything is running. So I will leave that to the end. I will do it at the end, delete the Falco installation and reinstall it so you can see it. But I'll prefer to start just using it first, so we don't have to wait those minutes. So the first rule we are going to test is a terminal shell in a container. This is a very important rule that's very basic, that it's very useful. So we have here a a cluster that has several nodes. We have the Falco deployment on each one of the nodes that is running and monitoring the kernel. We are going to use Stir to monitor the logs of all the Falco installations, and we're going to see how the logs are going to show or trigger of these rules. So for the first one, we're going to execute this command. This command is going to run a new pod in one of the nodes. The pod is going to be called debug. The image base is going to be Python. And we are telling it not to restart it and to remove it when it ends and open a shell. So this is something that a malicious actor can try to do to get inside our cluster. And if he succeeds doing this, he can run several commands, and then he can exit, and the pod is going to be deleted and disappear. So we may have no trace of what was going on. So this can take some minutes in some cases when the image from Python has to be downloaded. But we can see here that immediately Falco has picked up this detection. Shell has spawned in a container with an attached terminal. User root, blah, 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 the container ID, the shell command line. So it not only detects the event, but it also gives me some information about that. How to say, we also have other related rules that are similar to this one. For example, when a database binary spawns a shell, an interactive shell, that it's something that could be done, but I don't think any good developer is going to allow that for how they use the database. We have also rules that you can define SSH connections that are allowed, and then you're going to be detecting when one of those connections that is not in that list is detected. We are going to detect untested shell. We are going to detect user interactive. All those kind of rules can be triggered, are very similar to this one. So right now we are inside a pod already, and as we want to do bad things to this, we are going to download a malicious script that we want to run here. And this malicious script, I'm going to show it to you right now. It's in this URL. We're going to write it to a file that it's run.sh. It's going to be downloaded. Oh, but we have a new Falco rule detection here. File below the root folder or /root, open it for writing. Okay, Falco is monitoring several special directories for writing that should not be written in normal conditions, and the root one is one of those. Okay, what we have here. Let me see. So we have here a script that it looks like does something with a binary and a binary called CG miner. This is a known crypto miner in Python. And this script is going to try to overwrite the GCC binary that is used to compile files. And it's going then to execute it. So let me try it step by step, because I want to show two triggers of rules. Let's try first to download the crypto miner over the GCC binary. Okay, and as you can see, we have here a new detection. File below monitor directory operate for writing. And in this case, we see the full command of the execution for what has happened. So we know exactly what kind of file has been put inside this GCC. What's the malicious load here? And all the related information about the container, the pod, namespace, everything. Okay. And if I try to run this binary, let me take this out. It should have. I didn't put the permission in the file. Because I overwritten this. I think. Let me see what's going on. Okay, that was it. Very good. So I see that this is a crypto miner that is trying to connect to some non-crypto miner servers. It fails because one of them is down, and then it doesn't find GPUs to run because this one is optimized for GPUs. But it's good for our test. We don't want to mine here. We want to know that this Falco rule can detect the crypto mining running. So what the Falco rule is doing here now is intercepting the network connection, and it's detecting the protocol here. It's a Stratum. It's a very well-known protocol. And it's also detecting the domain that is on a list of known miner domain, okay? And then just for fun, let's try another thing. Let's try to find some sensitive files. So if I go and try to find, oops. For example, RSA, some private keys. Oh, if I write it well. Here you are. Also, Falco have got up this and is warning us, grep private files or private activity found. And we also have here exactly what command has been run and which container. So how is the anatomy of these rules? Let me go by it a little quick. Let's go about terminal shell. So terminal shell, we detect there is a spawn process. It's inside a container. We see it's not the zero terminal, and it's a container entry point. And then just with this, terminal shell has been detected. We can also look for a binary overwritten. Let me look for the rule I want. Well, I can't remember right now the name of the rule, but it doesn't matter. If we go for binary, here we have a rule that detects that you are writing inside the binary directory. In this case, binary directories are defined in a list. Here it is, /bin, /bin, user bin, user sbin. Okay, so we can modify this, and if we want to protect another file, another directory, we can just tell, okay, I want, I don't know, local being or something that we need to protect, or maybe I have something sensitive in bar my beans, anything we need. Okay. Okay. My favorite, the crypto mining rule. This is what it's about. So we have several rules here. We have two of them. One of them detects a TCP/IP connection, and the other one detects a possible mining running because of the protocol that it's using. In this case, the condition is just the macro. This is something that usually happens. Let me see there better. That does something several times. The rule just has the condition, so it's cleaner to have all the conditions you are using in different macros. So in this case, the system kernel event is a send message or send to, the directory is out, and you have a miner pool, HTTP or HTTPS or other. And you can see here, it's these addresses, the port that you are connecting, or you are using miner ports, and the domains. And here you have lists for those domains, more miner domains, and lists for non-ports. So if you want to update this rule and put more domains in here, you can change the list and put several domains you are aware of, and you can modify it very easily. So let's see for exfiltration, secret exfiltration. Let me see. What is the one I'm looking for? Oh, what was the name? Let me try again. Oh, I think the terminal just was dropped. No problem. Okay, no problem at all. Let's look for it, and that's all. Or let's look for find. Here it is. Private keys was the name. Okay. So for secret exfiltration, we have this rule that is going to try to detect the use of find and trying to detect that it contains the IDRSA file or IDTSA. Okay, this is a very specific one, but we also have other rules that are used for detecting other SSH rules, accessing the SSH directory. You have rules also that are useful in general, like where the log directories are tampered or the bash history is tampered. You have also other rules, like when you create a symlink. Symlinks are very important because if you try to create a symlink to another path, you maybe try to cheat with how the detection of the rule is done. But then you are going to be writing a symlink to a sensitive file. So that rule is going to trigger anyways. So you can't escape being detected this way. Let me see. So about how we write a new rule. So if we need to write a new rule, as I was saying, you should look for a rule that is similar to the one thing you are going to do. So for example, in the case of binary dir, right below binary dir, I have this part of the rule where I am detecting an event. I am detecting this open write, I can go by the macros and see how they are structured. So this way, I'm going to write my own version. I'm going to use, in this case, a placeholder macro that's going to do everything. So I'm going to detect the event. I'm going to detect that it's opening something for write. And then I'm going to add another macro that is a WordPress directory. And what this macro is going to do is going to test if the name of the file starts with this path that for me is in my system, the path for the WordPress installation, and if the name of the file that has been accessed for writing ends with .php or .ds. And having a rule like this is going to protect me from this kind of threat. It's very easy to write any rule that you want to use to protect files. And also similar to the one about crypto mining, it's very easy to write rules that you can use to detect connections that you want to be aware of, or maybe the other way around. You can do a wide list of connections that are the only ones that you want to permit, and then any extra connections or maybe any extra ports that are being used to connect that are not port 80 or something like that can be detected this way. And if you want to know about the syntax of Falco, things like this, the main resource for this is going to be falco.org. Let me see if my internet works. Sorry. I don't know what happens now with my falco.org. Come on, guys. There it is. Very well. So this is the main source of information you're going to find to know more about the rules, to know more how to write them, to know more about lists, macros, about all the keywords you can use to do your own detections, okay? All the supported fields for system calls, for Kubernetes events. Okay, so let's see. So how it's different, the Falco open source, Falco open source offering from what SysDig offers? Well, we are going to go a little quick about this. In this case, Falco handles the runtime detections, triggers those alerts, but those are sent to you, and you are the one that have to handle them. And you know that in this case, you should store them somewhere. You should trigger some kind of response to be able to work with that. But also in SysDig, we have image scanning for securing all the building process, configuration validation, the thing Pavel was speaking about at the beginning. Also for Falco, we have a better user experience, a simpler way to handle things, to be able to edit rules, to activate them, to combine them. We have a policy editor. We can stop containers as a countermeasure when a rule is triggered. We can we have captures. You can, whenever a rule is triggered, you take a few seconds capture of all that is running in the kernel. And you can even take a snapshot of things that were happening before the rule was triggered, because there is a circular buffer there that is always running. So whenever a Falco rule is triggered, you get like 10 seconds before and 10 seconds after of everything that's happened there. And that's the part about forensics, about incident response, and in general, a whole tool set to be able to satisfy compliance, security compliance of security standards a lot easier. I'm not going to go about every single feature here, just this is more or less a comprehensive list of everything you can find. And I'm going to show you very briefly what's this about. As I was saying, in Falco, in SysDig, you have this dashboard that you have all the policy events that Falco has triggered. You have the captures of everything that has happened, the visualization of all the infrastructure runtime policies that already have the rules inside them. And you can also browse the rules library. You have tags by security standard, things like that. And in this case, the activity audit that shows you the commands that have been executed when a trigger has been found. It's prettier to navigate. It's easier to filter by day, by date, by expression, that source, things like that. And those captures have a lot of information inside them of all what was happening in the kernel. You can filter and browse it. And of course, things that are not just runtime security, that's Kubernetes compliance checks with all the recommendations, and image scanning with reports about the images that are running in your system and if they are secure or not, are not secure, and why. This one has not been scanned. Let me show one that has been. And in this case, the scan of the images, you have the history of all the scan that has been done. Okay. So, a final thing in this demonstration I want to do, because I wanted to show you the installation. Let me show you. Okay, so I'm going to do this where this is going to be running. I'm going to delete the installation. All the pods are terminating. So let's start Falco the easy way. And the easy way, it's like this. Helm install, name of the installation, namespace, the chart, and the version. And it's going to span a daemon set that's going to deploy a pod on each one of the nodes of the computer or virtual machines. Each one of those nodes are going to use a kernel level probe that's going to inspect at the kernel level all the system calls, and it's going to only get information from those that are present in rules. And then there is a user space part of the binary that's going to run as a server to be able to send you the information, to interact with well, the things you say to it. And if I look inside it, you can see that it's installing the driver on each node. It may try to compile it, or maybe to download it from a precompiled list of binary for the probes, because the probe is tuned to the kernel version. And then there's an important part that I haven't mentioned. That's if you don't have access to the kernel level, because maybe you can run things those levels, this managed Kubernetes installation. You can get system calls using eBPF instead. That's eBPF. It's a standard when you want precisely to read Kubernetes. Read syscall events, and you don't want to provide access to that kernel because it's a very dangerous thing to do. So you just tap that eBPF source, and the kernel is going to send you the information by itself very easily. Okay. So this may take a little bit. That's why I didn't want to use it to start with, but it's not going to be very difficult. Okay. Additional resources that are interesting to know about. Of course, the Falco web page I already shown you. You have the Cloud Native Security Hub. There's a web page that has it has a classification of Falco rules and other kinds of rules like OPA and other things related to security, classified by kind of installation, program, a server. When you want to protect and put more security on a specific kind of installation in a very easy way. You have also access to information in blogs, like our blog. We are constantly sharing things about Falco open source, and you can find here this one that's for a classification of other rules following MITRE standard. Here is how to write several rules and other countermeasures to stop a malicious Python library that was detected the year before, and also a comparison between C/Linux, Seccomp, and Falco, and also one from Rancher that you have about how Falco works in Rancher. And so there are several other blog posts that you can access in our blogs. And I think it's time for Q&A.
Wow, yeah, that was an amazing presentation with so much information. We have a ton of questions, and we only have 7 minutes left. So we're going to try and go through them as quickly as we can. And if we need to stay a few minutes longer, we can, because at least then the questions will get answered in the video. Remember, everybody, that if you need to drop off, this is being recorded. If you could stay, great. We'll go through all of the questions. So let's start with. Somebody had a question about Sysdig Secure, but it looks like your colleague answered that already. Okay, we'll just start at the top. So does Falco need privileged permissions to be able to catch all of the system calls, kubelet logs, and so on? And if so, could it then become a security hole itself or a security vector?
That's a very good question. That's a very good question. In the case of system calls, it has to install a kernel level probe. And that happens on deployment only. It's a one-step installation. But also, if you are concerned about security in that way, you can instead activate eBPF and just tap into the eBPF stream that the kernel is going to send to Falco. It's a more secure way to not give access to all the kernel.
Jorge asks if you can use Falco to protect the Nginx ingress controller.
You could. And we were working on new Falco rules, for example, to detect several things related to more networking way of work of things. Like, for example, you can detect if an ingress controller has been deployed without a certificate, a valid certificate, because maybe you did that for testing and you left it that way. Or you can do a list of sources that can receive connections from outside of your cluster, and detect whenever one of your pods receive a connection that it's not inside your cluster. So only your ingress should receive this connection inside, and all the other pods should be just private. So you can also detect that kind of things.
Nice. Valerio asks, what's the footprint of Falco in terms of resources on the Kubernetes nodes?
Yeah, that's a very good one also. It's very low. It's in test we do, it's like 5% of CPU tops. And okay. I have to say that this is the real achievement here for Falco, because doing these detections, reading system kernel calls, things like that could be done several ways and could be done by anyone. But being able to do that in a way that doesn't needs many resources is the hard part of how Falco works.
There have been a bunch of questions that came across where people are asking if this works with hosted Kubernetes providers. We saw AKS, EKS, GKE. Somebody's asking about IBM Cloud right now, and they all seem to come back to the fact that when you use a hosted Kubernetes cluster, you don't have
Mhm.
access to the master nodes. So how
Yeah.
can you gain access to the logs and to all of that data?
Okay, so it can be used in this way. We are going to need to work with eBPF, and also for the Kubernetes audit, we want to tap to the webhook of that the master node expose. But each one of the Kubernetes installation may require somehow different steps to do that. And we usually provide information about how to deploy on every one of those environments. And you could share our blog in our website, because whenever we try a new installation, new integration, our team always writes a new blog post explaining how to do this in this kind of environment. So we are always looking to make it easy to do that kind of thing.
Sounds like your blog is a good place to check back frequently for
Yeah,
new information.
yes, it is.
Tomas asked if Falco is creating differentiated snapshots of the kernel before and after some incident.
No, it isn't. It isn't. And the thing is that here Falco is not blocking the kernel. It's not stopping things from happening. It's working like in a buffer way. It gets a buffer of calls and it's analyzing them in parallel, but that prevents it being a very a resource hog that takes a lot of resources from it, and it wouldn't work if you try to get inside each one of the calls and stop it until it has been processed. So in this case, we rely only on notification, and you can also take a measure when you have a detection, but it's not like from the very first kernel system call that you are receiving in this case.
The next question is from somebody whose name I know I'm going to pronounce wrong, and that's one of the things I dread about webinars is trying to get everybody's name correctly. So this is,
Mhm.
I'm going to try my best. Oh wow, Ijewi? Anyway, this gentleman,
This
this
gentleman,
individual
yeah.
asks if there's a macro for etcd.
For etcd,
Yeah.
for etcd, I don't know. I don't know. I don't know. But
Okay.
to do what exactly was with etcd?
Yeah, okay. So there's not more information in the question, but
Okay.
if you would like to respond, the person whose name I can't pronounce, and ask another question with a little more detail, we'll try and get that one answered as well. All right.
Okay.
So those are all of the high priority questions, and we'll go through some of the ones that remain. Uh,
Right.
David asks why we need to install kernel headers and kernel devel to run Falco on CentOS.
Very good question. The thing is that Falco is very specific to the kernel you are using. And depending on how you are installing it, it's going to try to install from the source, try to compile the kernel module you need. So to
Mm,
be able to do that, you're going to need the headers. But there are there are some projects on the Falco GitHub page that are for trying to have pre-built modules where you specify the headers, the things you are going to use. You use Docker to download those, and you just like prepare beforehand a Falco kernel probe. It's not easy to do, but uh, we are working on making it easier each time.
we have a follow-up to that etcd question where the individual just wants to know if Falco could be used to monitor and protect against attacks against etcd.
Well, it should. We already have rules. For example, when you access the AWS endpoint from inside the cluster, we have anomalous connections to the master node from the worker nodes, I believe. So I think you should. I think you should.
Okay,
Yeah.
cool. Is there a minimum Kubernetes version that people need to be running in order to use Falco?
Yeah. usually new releases are targeted at the last 3 versions. That is more or less standard in Kubernetes for any other project. And
Yep.
sometimes if you go to an older version, it's going to work for an older Kubernetes version also, but you have to go for an older Falco version to be able to do that.
Okay. Sergio wants to confirm that Falco rules.yaml is the predefined configuration and that custom rules should go in Falco rules.local. Is that correct?
Yeah, that's a good question also because I haven't talked about that. You have this file that is Falco rules local, and this file is just comment empty, and you write your own code here, and it's going to be executed after all the rules, overriding those rules. So you can customize those lists, those macro, or anything you want, just writing code here, and it's going to be read at the end of the installation of the
Very cool. Nikhil asks, how is the default Falco rules.yaml updated?
Well, in the case of the Helm chart, when you upgrade, the content is in a config map, and it's going to be updated when you update all the Falco installation. So Falco is at the same time the probe, the user space binary, and the Falco rules, and everything is updated. So I've shown here in the presentation modifying this file by myself. I think that was not a very good example. I should have written here in Falco rules local, because this is the file that is preserved. Everything else can change, but you know, whatever you put here is preserved for you and never updates.
Right. So as long as we're talking about the default rules that get installed with the chart, Stefan asked how many CVEs are covered by the rules. And I was going to answer that by saying that I imagine your guys' intent is to cover all CVEs, regardless of how many there are. Is that
Yeah,
accurate?
well, the thing is, yes and no. The thing is that Falco rules are not classified by CVEs. There
Okay.
are many CVEs that are not detectable at the kernel level, maybe, that comprises other kinds of things. And how the Falco team, the open source team, has thought how to manage this is that they think specific CVEs should live in the let me show, in the Cloud Native Security Hub. Like if you want to address a specific CVE, you're going to put it here. But if you are that CVE is about a specific program you're not running, you don't want a Falco rule about that, you're going to find it here. But if it's something that is general in the Linux open source landscape or Kubernetes or something like that, then you're going to find it on Falco.
Okay. Good answer. Lynn asks, if a binary violates a Falco rule, would an attempt to run that binary when it doesn't exist in the container environment, for example, if it was removed due to hardening, trigger a Falco alert?
Yes, because we are working with the nodes at the kernel level, and we are detecting things even if you don't have Kubernetes running. So if you imagine you have your own machine, you deploy Kubernetes using Minikube or Docker or whatever, and you have a Linux machine, so you're sharing your own kernel. Your Falco installation in your machine is going to detect things on your machine, not only inside of the cluster. And you're going to see everything. Nothing is going to escape you.
Okay. Scrolling through, always at the end of the webinar, because I'm replying to people, I'm like, thanks for your question. And there's like, you're welcome, you're welcome, you're welcome. So I'm scrolling through to pick out
I see there's a
the
lot.
remainder of the questions. Yeah, no, everybody in these
I
things is
didn't.
super friendly.
Oh, very nice. I wasn't aware there was so much. I had the window smaller.
Oh, yeah. No, it's been very popular. Victor asks, is there a way to change or obfuscate Falco to avoid its detection by attackers?
Oh, good question. That's what attackers would want, isn't it? Well, maybe if they do things that are not covered in a Falco rule, they want to avoid it, obviously. I think if maybe there are detections that are not at the kernel level. You're going to be able to do something, or you may use like legitimate sources, legitimate domain names, and orchestrate like you hijack a legitimate library. You could also overpass it, but it's going to be difficult. It's going to be difficult. And if you can come up with that, I think nobody's going to be able to detect it, because at the kernel level you see everything. It's
Right.
it's not going to escape you. Yeah.
Okay. Are there any rules specific for Rancher? That's a question from David.
Yeah, no, they are not, because in this case for us, Rancher is another Kubernetes installation. So
Just a Kubernetes installation, right?
yeah,
Okay.
not needed in this case. But all the Kubernetes roles work with Rancher.
Yes, of course. Anderson asks, does Falco scan? Okay. Sorry, the question is a little pieced together. I believe that that Anderson is asking if Falco can do image scanning for security vulnerabilities inside of container images themselves.
No, it's not designed to do that,
Okay.
because it's a whole different problem there. You should use other kind of project for that.
Not what it's designed to do. All right.
Yeah.
Vikram asks, what options do we have for patching issues that it detects? Can we do anything inline to fix stuff?
Well, we have several sub-projects, not very big ones, but let me show you about Falco response engine, for example. And let me show you also Falco sidekick. I left these two out because they're not very talked about. With the Kubernetes response engine, you have the Falco installation. You connect it to an apps for handling messages about all the triggers that have been detected, and then you can run kubeless functions as a service. So they take action. They run what's called a playbook, some kind of command that is going to be executed as a response to that rule. So this could be done, but you have to put all the pieces together to execute this.
Okay.
And also for the sidekick, it's a helper to make it easier to send the events to other sources. In this case, Slack, a very popular one, Opsgenie, SQS, etc.
Okay. That was the last question. So I have one final question, which is if people wanted to go somewhere and get started with this, what's the best place that they can go?
Obviously, the main Falco website, falco.org, where you're, it loads this time, where you're going to find all the information. But also at GitHub, one thing that is very interesting about Falco is that not only the source code of Falco is open source, but all the process of how Falco as a project is managed is based on the repository, and all the decisions, the discussions, the meetings, how the strategy of what should and should not be done. So you can influence things like that, sometimes just sending a pull request to some folders that are more about how to handle the project and not the source code. Okay.
Very cool.
And we also have the Cloud Native Security Hub. So if you go to securityhub.dev, it's a great place for you to discover and share security best practices and configurations for Falco.
Okay.
And if people wanted to learn more about the enterprise offering that you guys have, how can they reach out to you to get more information about that?
Yeah, that's a great question. They can go to sysdig.com and navigate to the product pages, as well as sign up for a 30-day free trial. which allows them to play with the commercial product as well.
Awesome. Okay, I have no more questions. So, do you guys have anything that you wanted to say in closing?
Thank you so
No,
much.
thank you everybody.
This is great.
Okay.
Hopefully this was useful for you.
So, my thanks to all of you who attended, and greater thanks to the 110 of you who stayed for the extra 10 minutes. I hope that you learned a lot. I hope you take Falco for a test drive and go take a look at everything that Sysdig has. They have a lot of really fantastic products, both in the open source space as well as in the enterprise space, that can help you across your entire infrastructure. So thank you, gentlemen, both for joining me in the webinar today, and I look forward to seeing you again in the future. All right, everyone, have a great rest of your week. Bye.